Hello, welcome to our Lab 4 for Physics 2 to 11. I'm Matthew Mazzacano. So what I'm going to be talking about today is an experiment as well as the physics concepts and laws that I am examining throughout the experiment. The simulation of that experiment and coding I used in order to calculate data from that simulation, and a little bit about what my results mean. So the experiment that I'm looking at today is I observed this spring with a mass attached to it oscillating in 2 dimensions of motion. So by two dimensions, I mean not just straight up and down, and not just left and right. Is moving in 2 dimensions. So I measured the different types of energy throughout the motion of the spring mass and how it changed throughout the spring's motion. Below this, you'll see some formulas for the different types of energy that I'm measuring throughout my experiment. So here's a little look into the tracker, which is what I used to analyze the motion of the video of the experiment. So yeah, this spring was oscillating in the x and y direction, in the x and y plane. Alright, so about this experiment, we are using Newton's second law of motion as well as the energy principle. And we are assuming that the only forces acting on the mass are the force of gravity and the spring force. The only energies are the gravitational potential, spring potential, and kinetic energy. The spring only moves in the xy plane. G is equal to 9.8 meters per second squared. And also, which I did not write, is that the mass of the spring is 0. So here's a little bit of coding. So we start out, the most important things here is that I calculated the spring constant by using a derived formula and the period of time for each oscillation of the spring mass. Here is the formulas for the energy, which I'm calculating throughout the simulation. You saw these up here. Moving on, the most important thing here is that we are updating the energies throughout the simulation. Force of gravity is negative mass times g. G is 9.8 meters per second. Too far. Yeah. So mass of the mass of the mass, and g. Force of the spring is the spring constant times the stretch of the spring times in the L hat direction, and the net force is the force of gravity plus the force of the spring. Here we're using Newton's second law to get the mass's velocity as well as the mass's position and updating it. Here we are updating the energy throughout the simulation, and then finding the change in energy for each type of energy. And that's all for the coding. So moving on, is the energy principle satisfied? Yes, the energy principle is satisfied because the total energy is constantly 0. Here, the total energy is represented by this orange line. We see it's constantly on the 0 on the x-axis. And all of the different energies are seen to oscillate back and forth, showing any change in the energy is that the energy is being transformed into other forms of energy. It's not being lost. There's none added, or there's none being lost, like I said before. Lastly, we are going to compare the periods in the x and y direction. So the period is estimated by calculating the time in between each crest or between each trough. So for the x direction, I used the troughs. I estimated as 1.646 seconds for each period in the x direction. For the y direction, I used the crests of these graphs, and I found that the period in the y direction is 1.519 seconds. So both of the periods are pretty similar. They only differ by 0.01 seconds. Oh no, sorry, 0.1 seconds. And that this error could have been caused by human error or just not having enough points to track the spring mass throughout its motion. However, the difference in the periods is enough to change the spring constant, so I used the period from the y direction in order to calculate the spring constant. And that is all. Thank you for listening and tuning in.